Artificial intelligence is frequently framed as a technical monolith, a domain reserved for those who have mastered advanced calculus and neural networks. This perception creates a specific kind of anxiety. For non-technical professionals, it feels like the new economy is being built behind a wall they aren't equipped to scale. But that assumption is outdated. Modern AI has reached a point where significant results are achievable using nothing more than plain English. Without writing code, you can generate complex marketing copy, automate multi-step workflows, and extract patterns from massive datasets. If natural language is this effective for high-value tasks, the practical necessity of learning to code changes. We have to identify exactly where plain English stops working. Most people interact with AI through pre-built interfaces and chat boxes. This is no-code AI, where the software acts as a translator, turning your instructions into the raw technical execution happening in the background. Working in this space requires a mastery of prompt writing. Success depends on your ability to provide the machine with precise instructions, a specific persona, and clear operational constraints. The difference in output is stark. A vague instruction leads the AI to produce something irrelevant, like a banana, while providing precise parameters ensures you get the exact result you need, like a stapler. Getting that result requires problem framing. You have to define the specific creative or business challenge you are trying to solve before you ever engage with the tool. Even then, you need the critical thinking to evaluate the results. AI can confidently produce errors or biases, and it takes a human expert to verify whether the output is actually useful. In the no-code space, the value of the system is driven by your domain knowledge and your ability to communicate. Technical barriers are replaced by the need for clear, strategic thinking. Eventually, every off-the-shelf tool hits a fixed boundary. Templates cannot accommodate specific complexities, like integrating AI with a private corporate database or training a model on proprietary information. The pre-built tool simply isn't designed for these connections. This is the technical ceiling. It is the point where natural language becomes too imprecise to manage the underlying data. Breaking through requires a different toolkit, APIs to connect systems, and programming languages like Python. Using code provides direct control over data pipelines, allowing you to build custom error monitoring and dictate how a model handles sensitive information. This marks the transition from operating an off-the-shelf product to engineering a custom system. At this stage, programming is less about inventing complex mathematics and more about managing the logic of how data flows between different tools. Learning to code is the path toward becoming an architect of AI rather than a consumer of it. You don't have to choose between being a non-technical user and a full-scale engineer. The relationship with AI is a continuous ladder. The most efficient way to learn is to start with plain English tools and use them until you encounter a specific technical failure that prevents your project from moving forward. When you hit that limit, you learn only the code needed to solve that bottleneck, keeping learning focused on practical results. If your goal is individual productivity, the bottom of the ladder provides everything you need. But if you intend to build entirely new applications or manage complex production-grade systems, the higher steps are required. The most successful professionals in this field prioritize hands-on experimentation. They allow their projects to dictate which technical skills they need to acquire next. AI does not demand that everyone becomes a programmer on day one. Instead, it offers the greatest leverage to those who are willing to expand their technical capabilities as their ideas grow more ambitious.